This is the video for lesson number 10-3, box and whisker plots. We're going to talk about box and whisker plots today, and we're going to define it as a graphic way to display the median, quartiles, and extremes of the data set on a number line to show the distribution of the data. There are 5 data points that are represented in a box and whisker plot. So we're going to talk about those 5 data points. The first one is called the minimum or lower extreme. This is the smallest number in the data set. We have a maximum or upper extreme. This is the largest number in the data set. The lower quartile or first quartile. This is the median of the lower half of the data set. We have the median or second quartile. This is the middle of the data. We have the upper quartile or third quartile, and this is the median of the upper half of the data. We also have what's called the interquartile range, which is Q3 minus Q1. We'll talk about that in a minute. And then outliers. We'll talk about how to find those as well. Okay, so let's go ahead and look at this box and whisker plot and identify the different parts. First of all, the min is the smallest number of the data set. So right here is our min. So I'm going to zoom in just a little bit so we can see a little bit closer. So this is our min, the left-hand side. This is the smallest number in our data set. Q1, the lower quartile or first quartile, is the left side of the box. This is our Q1. The median, or Q2, is right here. We usually just say the median, though. Then the right-hand side of the box is what we call Q3, or the third quartile, or the upper quartile. Then the right-hand side is our max. This is the biggest number in our number set. Okay? Now, if you'll see, this is divided into quarters, into fourths. So the left-hand side right here, this is the lower fourth, or 25% of our data. So this is the lower 25% of our data. Our 25% of our data is represented on this left whisker. Then we have 25% from here to here. Okay, so we have another 25% represented in the left side of the box. On the right side of the box, we have another 25% of the data. And then the right-hand side, the right whisker represents the upper 25% of our data. All right, then we have what is called the IQR, the interquartile range. I'm going to flip this around for a second. I can't draw that upside down. Okay, the IQR is Q3 minus Q1. That is the right side of the box minus the left side of the box. Tells me my interquartile range, how much it varies in the middle 50%. Okay, then we have our outliers. Outliers are a data point that's different significantly from the rest of the data. We still use this to calculate our data, but we need to understand how to find it. So determine if an outlier, if I want to know if it's an outlier out here on the right-hand side, I do Q3 plus 1.5 times the IQR. And if that data point is larger than that number, then it's an outlier to the right. If I have a data point that is Q1 minus 1.5 times the IQR, if it's less than that over here on the left, then I have an outlier to the left. We're not going to spend a lot of time on that, but that's how you find it. Okay, the box and whisker plot below represents the points students earned on a term project. Each section of the box and whisker plot represents 25% of the data. So we need to realize that this left whisker is 25%. This left side of the box is 25% of our data. The right side of our box is 25% of our data. And the right whisker is also 25% of our data. We also need to label our 5 data points. So we have our min. We have our Q1. This is our median. Q3. And our max. All right, so what is the min? So I'm going to come over here and I can see the min is 50. What is the max? The max is 350. What is the median? The median is 200. What is the first quartile that is the same as Q1, or we call it the lower quartile? And that is 150. What is the third quartile? That is Q3 or the upper quartile, and that is 300. What is the IQR? Remember, the IQR is Q3 minus Q1. So we're going to get Q3, which is 300, minus Q1, which is 150, and that gives us 150. That is the IQR. So I know the middle 50% varies by 150 points. Okay, 50% of the data is between, what percent of the data is between 50 and 300? So if I'm looking between 50 and 300, I have 25% plus 25% plus 25%. That is 75%. So I know 75% of my data is between 50 and 300. That means 75% of the students score between 50 and 300 on this project. What percent of the data is between 200 and 300? So between 200 and 300, that is 25% of my data. What percent of the data is between 50 and 200? So I have 25% here and 25% here. This is the lower half, so that is 50%. Okay, what percent of the data is between 50 and 350? So I have 25% plus 25% plus 25% plus 25%. That is 100% of my data lies between 50 and 350. So I know 100% of the students earned between 50 and 350 points on here. If 80 students are represented in the box and whisker plot, how many students earn between 300 and 350 points? Between 300 and 350, 25% of them earned that score. So if there are 80 students, I know that 25% earned between 300 and 350, which gives me 20 students. Okay, if 80 students are represented in the box and whisker plot, how many students earn between 150 and 350 points? So between 150 and 350 is 75% of my data. So I have 80 times 0.75, which gives me 60 students. The one thing to remember about a box and whisker plot is the box and whisker plot tells us how our data is distributed. It breaks up into fours, okay? But we cannot tell from our box and whisker plot how many data points are in there. So like in this situation, we don't know how many students were in this sample set, okay? We just know that 25% were between 50 and 150, 25% were between these two, 25% was here, and 25% is there. But we don't know how many were there. But we can predict. We can say, well, if there were 80 students, we know that 20 of them would have lied in this area. Or we could have said if there were 200 students and predicted that. We are going to now construct a box and whisker plot. So let me give you your data. We have the numbers 1, 1, 2, 3, 4, 5, 6, 8, 10, and 16. Those are the numbers I'm going to be using to create my box and whisker plot. First thing I want to do is find the median of this data. There are 10 numbers here, so my median is going to be the middle between 5 and 6. So 1, 2, 3, 4, 5. There's number 5 and number 6. These are the numbers 5, the 5th number data set, and the 6th data set. So my median is right in between. So I know my median is going to be 4.5. Now we want to find the median of the lower half and the median of the upper half. Depending on which textbook you look at, depends on if they include the median when finding this. We're not going to include the median when finding this. Some textbooks do it that way, some do not. On all of your tests that you have anything with us, we'll take either answer. Okay, so on our test, it doesn't matter if you use it or not. You'll get the same answer. Okay, so the median, in this situation, we're not going to include it to find the median of the lower half of the data. Okay, so once again, it does vary depending on which textbook you look at. Some textbooks say yes, you use it. Some textbooks say no. Both methods are valid, though, in the world of statistics, okay? All right, so we're going to go ahead and find the median of the left-hand side, and that's going to be 2. That is our Q1. We're going to find the median of the right-hand side. That is 8. That is our Q3. 1 is our min, and the right is our max. So you can see our box and whisker plot is starting to take form just right here. I can see this is my box. This is the left side of the whisker, and the right side of my whisker. Now, the 16 here seems a little significantly different than the rest. So I want to double check to make sure it's not an outlier. I'm not sure. It's right there on the edge where I'm like, it could be an outlier, could not be an outlier. So I need to just check that. So remember that the formula to tell if it's an outlier or not on the right-hand side is whatever Q3 is plus 1.5 times the interquartile range, which is Q3 minus Q1. Okay, so I'm going to go ahead. Q3 is 8 plus 1.5 times Q3, which is 8, minus Q1, which is 2. So I'm going to put that in my calculator, and I have 8 plus 1.5 times 8 minus 2, which is 6, and that gives me 17. So is 16 greater than 17? And the answer is no. So 16 is not an outlier. It's really close, but it's not greater than 17. Even if it was 17, it still would not be an outlier. It had to be like 17.1, anything greater than 17. So this is not an outlier. Kind of looks like it might be, but it's not. Okay, let's go ahead now and construct the box and whisker plot. So we're going to go ahead now and put our numbers along this number line here. I'm going to go ahead and start with 0. Okay, there's our number line. So we have that the min is 1. That's the left side of our whisker. The left side of our box is 2. Our median is 4.5. That is the middle of the box. The right side of the box is 8. And the right side of the whisker is 16. It's all the way out there. Okay, so there's our box and whisker plot. Okay, so what is the median in this situation? Well, in this situation, our median is 4.5. It says, what is the lower extreme? The lower extreme is the same word for the min. What is the min? The min in the situation is 1. What is the upper extreme? That is the same word as max. So what is our maximum number? That is 16. What is a lower quartile? That's the same thing as saying, what is Q1? Q1 in this situation is 2. What is the upper quartile? That's the same as asking, what is Q3? In this situation, it's 8. What is the interquartile range? That is Q3 minus Q1. So we have 8 minus 2, which is 6. Okay, now it wants to know, how does the median compare to the mean? So in order to figure that out, we need to first of all find the mean. I can do that here because I have all the data points, okay? If I was just given this, I don't have all the data points. I only have 1, 2, 3, 4, 5 of them out of the 10. But since I have all the data points, I can find the mean. So I'm going to add all these numbers up. So I have 1 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 8 plus 10 plus 16. When I add all those up, I get 56. Then I'm going to divide by the number of numbers I have, which is 10, so that gives me 5.6. That is my mean. And how does that compare to the median? The median is 4.5. So this is greater than 4.5, which is the median. So I'm going to write a statement telling me how those two compare. So I'm going to say that since 5.6 is greater than 4.5, the mean is larger than the median. Okay, we're going to construct a box and whisker plot again here. And our numbers this time are 1.1, 1.2, 1.5, 1.7, 1.8, 1.8, and 1.9. In this situation, I have 1, 2, 3, 4, 5, 6, 7 numbers. So the middle is going to be number 4. There's our median. Now I want to find the middle of the lower half of the data, which is going to be 1.2. So this is my Q1. This is my median. And then the middle of the upper half of the data, this is my Q3. This is my max and my min. And you can see right here, this is where our box is, and these are the 2 whiskers. We're going to go ahead now and put those data points down here. Okay, so my min is 1.1, that's the left side of my whisker. 1.2 is the left side of my box. 1.7 is the middle of my box. And 1.8 is the right-hand side of the box, and 1.9 is my right whisker. Okay, so what is the median? The median is 1.7. What is the min? 1.1. What is the max? 1.9. Okay, what is the first quartile? First quartile is Q1, that is 1.2. What is the third quartile? That is 1.8. What is the interquartile range? That is my Q3 minus my Q1, which is 1.8 minus 1.2. That gives me 0.6. How does the median compare to the mean? So once again, I need to find the mean. So I'm going to add up all those numbers. I'm going to say 1.1 plus 1.2 plus 1.5 plus 1.7 plus 1.8 plus 1.8 plus 1.9. When I add all of those up, I get 11. Divide by how many numbers I have, which is 7. It gives me approximately 1.6 for my mean. My mean this time is smaller than my median, which is 1.7. So I'm going to write since 1.6 is less than 1.7, the mean is smaller than the median. Now, in this situation, I absolutely could have said since 1.6 is less than 1.7, the median is larger than the mean. As long as it's a true statement, it doesn't matter which way you write that. Okay, we're going to start comparing data now. I'm giving you box and whisker plots. I have Class B and Class A, and these are their test scores. Okay, so in Class B, the upper 50% scored above what number? So I need to find the upper 50%. Upper 50% would be this right here. So the upper 50% of the class scored above 79. Okay, in Class A, the upper 50% scored above what number? So once again, I'm looking for the top 50%. So that's from our median on up. So this one is 70. Okay, what does the interquartile range of Class A represent? Well, what is the interquartile range? That's going to be Q3 minus Q1. So that is 78 minus 65, which is 13. That's my IQR. What does that mean? That means that the middle 50% of the students scored between 65 and 78 points. I can also write that to say the middle, so I'm going to go a little bit more over here to the side, the middle 50% of students scored within 13 points of each other. This one's actually a better explanation of what the IQR stands for, since the IQR is 13. So I would actually put the middle 50% of students scored within 13 points of each other. That means that the middle 50% only varied within 13 points. Okay, which class had an outlier? That would be class B. Right there's our outlier. And what does this outlier mean? This means that one person in class B scored significantly lower than the other students. Okay, so one person in class B scored significantly lower than the other students. That's what that outlier right there represents. Okay, our last page. Which class had a greater range in test scores? Explain. Okay, let's go back now and look at this class. We're still going off this same question here. Which class had a greater range in test scores? Well, let's see what was the range. The range is the largest number minus the smallest number. So here is 88 minus 50, which is 38. This one is 90 minus 50, which is 40. So class A actually had a greater range in test scores. So class A, and that is because they had a range of 40, and that is greater than 38. I'm going to put a B up here, and this is class A. Okay, the upper 25% in class A scored above what number? So the upper 25% in class A, scored above 78. The lower 50% of class A, so the lower 50% of class A scored below 70. The middle 50% of class A scored between 65 and 78. And the lower 75% of class A scored below, so the lower 75% of class A scored below 78. And the upper 50% of class A scored above 70. Which class performed better on the test? So if I look here, this is kind of a tricky question. Which class performed better? Even though class A had the highest score, if I look at percentage-wise though, if I look at the top 25 or 75% of class B, 75% of their students scored above 72, and only 50% of their students in class A scored above 70. So class B actually did much better than class A overall. So class B, and that is because 75% of class B scored above 72. And 50% of Class A scored above 70. So Class B had 25% more students do better than Class A. Okay, we're going to go ahead now and do this last page here, this last question with regards to the average high temperatures for 12 months in Boston, Seattle, and Tucson. So we know Boston is in Massachusetts, Seattle is in Washington, and Tucson is down in Arizona. Okay, this is the Northeast, this is the Northwest, and that is the South, the Southwest over there. So we're definitely going to have some different variations there. You can see how definitely the Southwest is going to be much warmer than the Northwest. But the Northwest, because of the way that the climate is over there, it's more of a rainier climate, is warmer than Boston in general. But we've got those high months over here as well. So let's go ahead and look at what's going on here. Okay, so the upper 75% of Tucson's high temperatures were above what number? So if I look at Tucson, 75% were above 60, and that's degrees. The lower 75% of Seattle's high temperatures were below what number? So the lower 75% of Seattle were below 65 degrees. Okay, so find the range of each city. What is the range of Tucson? So to find Tucson, I'm going to take the max minus the min. So I have 90 minus 55, which is 35. Seattle, the max is 70 minus 40, which is 30. And Boston is 75 minus 25, which is 50. So we can see that Boston's temperatures vary the most. Those definitely vary the most there, okay? All right, so find the interquartile range for Boston. That is our Q3 minus our Q1. So 65 minus 35, which is 30. The middle 50% of months in Tucson are between, so the middle 50% are between 60 and 85. Then we have the upper 25% of the months in Boston are above. So if I look at Boston, the upper 25% is above 65. And that's degrees. The median monthly average temperature in Tucson is. So what is the median in Tucson? If I look up here, the median is the middle of the box, and that is 70. I'm forgetting my degree signs here. Go ahead and add those in. What does the upper quartile of Seattle mean? What does that mean, the upper quartile of Seattle? So that means that 25% of the months, their average high temperature is between 65 and 70. Or I could just say it's above 65. So we're going to go ahead and say, what does the upper quartile of Seattle mean? So 25% of the months, which 25% of the months would be 3 months, okay? So 3 out of the 12 months, the average high temp is between 65 degrees and 70 degrees. So what does the lower quartile for Tucson mean? What does that represent? That means the lowest 25%, the average high, is between 55 and 60 degrees. So 25% of the months, the average high temp is between, let's go back, 55 and 60 degrees. Okay, it says, can you find the mean monthly temperature for Seattle? So do we know how many temperatures were calculated in this? And do we know what they are? Do we know each data point? I don't know each data point, therefore I cannot find the mean. Okay, I don't have all the data. All I know is those 5 data points. Okay, out of all the data, I just know the min, the max, Q1, Q3, and the median. Okay, I can't find the mean from that, so no. We cannot find the median. We don't have all the data points.